Hello everyone, welcome to the second part of the PYQ series. Here we'll solve some more question based on probability. So let's get started with the first question. The question says if a fair coin is tossed 4 times, so here how many times the trial is being done is 4 times. What is the probability that 2 heads and 2 tails will result? So one way of solving this question, it can be like this: manually keep on writing all the combination where we are getting 2 heads and 2 tail, correct? But this is a linear process. So what we will do is we'll try to find the solution using something called as the binomial probability or the binomial distribution formula, correct? In this, we know that whenever the number of trials is large, what we do is we can apply the binomial distribution, because here we know the probability of success as well as the probability of failure. P is the probability of success, and that probability is getting head and tail. So what is the probability of getting one head in one trial? So it is going to be 1 over 2. And Q is thus the complement of P. So it is 1 minus P. We can write it as 1 minus 1 over 2, which is 1 over 2 only. And the binomial formula, we already are aware that if we have to find probability when x is equals to r, it is given by NCR P raised to r and Q raised to n minus r. So just use this formula here. Here the value of r is 2 because we need 2 head and 2 tails. So here now n is given to be 4. That is the number of trials. So NCR, which is 2, and P is already r. So 1 over 2 raised to 2, and again 1 over 2 raised to 4 minus 2. So this comes out to be 4 choose 2, 1 over 4, and this also is 1 over 4. Simplifying this, what we'll get is the answer at 6 over 4C2. We know it is nothing but 6 only, and 4 times 4 is 16. So further we can simplify. It is going to be 3 divided by 8. Hence, the correct option is going to be option A. So here is a second question. This is quite interesting question. What we have to do is we have to find what is the probability that divisor of 10 raised to 99 is a multiple of 10 raised to 96. So before starting, what we have to do, we have to just find the prime factors of 10, which is 2 and 5. So we can write 10 raised to 99 as 2 raised to 99 times 5 raised to 99. Correct. Now, if we try to find out the number of possible factors of this number, which is 10 raised to 99, it will be nothing but times 100 from here only. Because if we can write a number, let us take it as n, and the prime factorization is a raised to m times b raised to n. And if we have to find out the total number of factors, we know this formula. This is nothing but m plus 1 times n plus 1. So we have just used that formula. And here we are getting this as 10,000. So these are the number of factors. And also we need that 10 raised to 99 is a multiple of 10 raised to 96. So we can write it as 10 raised to 96 times 10 raised to 4. This is what we can do. Correct. Now, 10 raised to 99, number of multiple of 10 raised to 96 will be how much from this? If I write number of multiple of 10 raised to 96, which will divide 10 raised to 99, which will divide 10 raised to 99. We can see that will be nothing but just equals to number of possible factors of this. And here one change you do, this is just 1000, correct? Because 10 raised to 96 already we have written. So this is nothing but number of factors of 10 raised to 3, which is 1000. And we know that this is nothing but 2 raised to 3 times 5 raised to 3, which can be again using the same formula. The number of factor is going to be 3 plus 1 times 3 plus 1, which gives us 16. So this is our favorable outcome and this is the total outcome. Hence, if I write down the required probability, it is 16 divided by 10,000. Simplifying this, what we get is 1 divided by 625. So the correct option is going to be option A. So here is the next question. It says that a deck of 5 cards which are having a distinct number 1 to 5. So these are the 5 cards 1, 2, 3, 4, 5. They are being shuffled thoroughly. 2 cards are then removed one at a time from the deck. What is the probability that the 2 cards are selected with the number on the first card being 1 higher than the number on the second card? So what we'll do in this case now? Number on the first card. So let us say this is our first card. It can have the following numbers. And here we can write down our second card. It also carries 1, 2, 3, 4, 5. We have to consider those cases where the number on the first card is 1 higher than the second card. Like if you see the second row, which is first card is 2 and second card is, first card is 2 and second card, in that case, it has to be 1. Correct. Where I will write 1, 2, 3, 4, 5. So for corresponding to 1, I will not get any number. Similarly, corresponding to 5 on the second card, we don't have anything on the first card. So what are the possible cases? So this is our first case where the number on the first card is 1 greater than that of the second card. And so we have total 4 cases. Correct. So these are the favorable outcomes. So number of favorable outcomes from this we get as 4. And what are the total number of possible ways? Total number of possible ways of picking up the cards, they are being picked up one by one. Correct. So when we are going to pick the first card, we have 5 choices. For the second card, we have 4 choices. So it comes out to be 20. Hence, we can write down the required probability. It is going to be favorable outcomes divided by the total number of outcomes, which gives us the answer as 1 over 5. And the correct option is option A. Moving to the next question. It says that we have 4 fair 6-sided dice. So 4 fair 6-sided dice, the probability that the sum of the results being 22. Probability that the sum is equals to 22 is given to be x over 1296. This we can do by a guesswork. Like if we have 6-sided die, so minimum sum if we write down here, what is the minimum sum in this case? It is going to be 1 plus 1 plus 1 only, that is 4. And if we talk about maximum sum, it is going to be 6 plus 6 plus 6 and 6, which gives us 24. We need the sum to be equals to 22. So we have to consider the cases which are more or less closer to this part. So how many combination we can make for 22? So we can have 2 cases if you think. Like we have taken all 3 as 6 and then 1 4. In this case, we'll get the sum as 22. Or it might be the case that we have 2 6 and 2 5, which gives us the value as 22. But here we can have different types of permutations of the 6 can be on the first and fourth and second, fourth can be on third, means they can be different arrangement of these. So we have to consider all those as well. So here what we get is 4 factorial divided by repetition is of 6. 3 times so divided by 3 factorial, which gives us 24 divided by 6 as 4. Similarly here, how many combination we can create? So 4 factorial, sorry, how many permutation we can create? It is 2 factorial times 2 factorial, which is again 4 times 4, which is 16. Sorry, 2 times 2, it is just 4. And this is going to be our 6. For total number of ways to get sum as 22, it is going to be 10. Hence the required probability, if I write down what are the favorable cases, we have 10 over 1296, and it is given that this is equals to x over 1296. So comparing both of them, we get the value of x is equals to 10. Hope you understood the concepts. Thank you for watching.